Mr. Clown here. Today we're going to be looking at the discriminant. What is the discriminant and how can I use it to work out the nature of the roots of an equation? If this is your first time here, please remember to give it a little like and consider subscribing to this channel so that you can keep updated with maths, especially in this difficult time when we're going to be off school for a while. Let's get straight into it with what is the discriminant. Okay, let's talk about the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. Now the bit underneath the square root sign is called the discriminant. That is the bit we're going to be using to work out whether the nature of the roots of a quadratic are real, are not real, or are equal. So I'm going to show you a few graphs what we can do to look at that and see what we get from the graph, what the roots are, how many roots a quadratic has, and then show you how to use the discriminant without drawing the graphs to work that out. So let's go straight into that. So let's look at the equation y equals 2x squared plus 4x minus 3. That has the roots crossing, you can see on the x-axis there. It's got two roots then obviously. And so we say that it's got two real and distinct roots. Distinct just mean different roots, okay? Let's look at another one. Of y equals x squared minus 6x plus 9. You would see that you would have just the turning point touching the x-axis. So it's got a root. The turning point touches the x-axis, so it's got one root, okay? So instead of saying it's just got one root, we say that the roots are equal. It's got two roots, but they're both the same in other words, okay? Of y equals 2x squared minus 3x add 4, you can see there that it never ever actually crosses the x-axis. If it doesn't cross the x-axis, that means it's got no roots, because the roots are where it crosses the x-axis, and therefore we say it's got no real roots. The reason we use the word real would become apparent if you did higher, but for now we just say it's got no real roots. And we are going to look to see how the quadratic formula, which tells us the roots, we can use that, the bit under the square root sign, to work out what the roots are in terms of whether they're real, not real, or equal, okay? And we'll just do a few examples of using it and getting comfortable. Okay, so we've already seen that if you take the quadratic formula, which you're given at the start of a National 5 exam paper, you get this bit in the middle of it, the square root of b squared minus 4ac. The b squared minus 4ac part is called the discriminant. So that's the discriminant part here. And we can look at the various options. We've already seen that some quadratics have no roots, some have two real and distinct roots, two real and different roots, and some quadratics have equal roots. Now, if we just examine this a minute, we're going to, in the end, square root a number. B squared minus 4ac, once you work out what that is going to give you a number. And there's three options. You're either going to get a positive number, and if it's positive, that means that when you square root a positive number, you get two answers. Square root of 25 is 5, but it's also minus 5, so there's two real and distinct answers. So if this bit here is positive, you get two real, and I'm going to use the word different roots. So that's the first possibility, if it's positive. If, on the other hand, it is 0, so the middle option, well, if you square root 0, you get 0 as well. So the square root of nothing is nothing. There's no a positive answer and a negative answer. There's just one answer, which is 0. That means I'm only going to get really one root. But we never say it's got one root. We say it's got both roots are equal. And we're using the word real again. Both roots are real and equal. So that's your second possibility. And then your third possibility is you do the sum here and you get a negative answer. So let's say if you try and square a negative number, you can't do it, right? There's no number where you square it, the answer is negative. So if you can't square root this thing, you can't get any roots, so it's not actually got any roots. So we say it's got no real roots. So a little note on this word real. We use this word real because the set of numbers that we normally work with from minus infinity to infinity are called the real numbers. Later on in higher maths you'll learn this, we came up with a new set of numbers called the imaginary numbers, which do allow us to square root negative numbers, but we don't have to worry about that at this stage. We just use this word real because it is saying that we've got real roots or not real roots, okay? Because later on there is ways to do it with negatives, but at National 5 level, don't worry, doesn't matter. Just remember we need to use this word real when we are describing the roots, okay? Let's go into some examples. So simple example, example 1, find the nature of the roots of y equals 2x squared add 4x minus 3. So step 1 is we look for our quadratic formula. If we're doing National 5 right now, you would get that at the start of your exam paper, and we write down the bit underneath the square root sign. So your discriminant b squared minus 4ac is the bit we need, and we need to work out what our a, b and c is. So a is the number in front of x squared, so a equals 2. B is the number in front of the x, so b equals 4 in this case, and c is the final number on its own, so c equals minus 3. So I'm just going to substitute my 2, my 4, and my minus 3 into this, okay, and see what we get. So I've got 4 squared minus 4 times 2 times minus 3. That gives me 16 for the first term. Now that's a minus 4 times 2, which is minus 8. Minus 8 times minus 3. Double minus multiplied together gives you a positive. So minus 8 times minus 3 is positive 24. Add them together, 24, 40. Now the answer is not important, the number is not important. What's important is it positive, is it negative, or is it 0? This is positive, so I write a statement to say there are 2 real and different roots. B squared minus 4ac is positive. Okay, so that's example 1. Example 2 says find the nature of the roots of y equals x squared minus 6x plus 9. So like example 1, I'll find my quadratic formula and write down the discriminant, b squared minus 4ac. I'll work out my a, so that's 1, so there's nothing in front of x squared. B is negative 6, and c is 9. Substituting in here, so I've got minus 6 squared minus 4 times 1 times 9. Minus 6 squared is just 36. 4 times 1 is 4, 4 times 9 is 36, so take away 36. That gives me 0. So we know that if the discriminant is 0, there are 2 real and equal roots. So that's what I write down. 2 real equal roots, because b squared minus 4ac equals 0. That's as simple as that for example 2. Okay, let's go on to example 3. So the last simple example, then I'll do a problem solving example. It says find the nature of the roots of y equals 2x squared minus 3x add 4. So I write down my discriminant, b squared minus 4ac. This time a equals 2, the number in front of x squared, b equals minus 3, and c equals 4. So you've got minus 3 squared minus 4 times a is 2 and c is 4. Minus 3 squared is just the number 9. 4 times 2 is 8. 8 times 4 is 32, so 9 minus 32. We should really work it out. So obviously the answer is negative, but we'll work it out. 32 take away 9 is 23, so it's minus 23. So our discriminant this time is negative, and we know that if it's negative, I can't then square root the answer, so I can't find any roots. So I write down that there are no real roots, because b squared minus 4ac is negative. And that's your 3 basic examples covered, when it's positive, when it's 0, when it's negative. And we'll do one common problem solving question is the next example. Example 4 says find the range of values of k such that kx squared minus 4x add 2 equals 0, and k, it says here, doesn't equal 0, has real roots. So I'm looking to work out for kx squared minus 4x add 2, when does that have real roots? Well, if it ever talks about real roots or the nature of the roots, we know it's a discriminant. So I look back in my page, look for the quadratic formula and find the discriminant part, b squared minus 4ac. Now usually this would have a number here, and it doesn't have a number, so it's telling me that there's a bunch of numbers that k could be, and I need to work it out. I just go through my normal steps. A would usually equal a number, but this time it's k, it's in front of x squared. B equals minus 4, and c equals 2. So I substitute that into here. So I've got minus 4 squared minus 4 times k times 2. So minus 4 squared is 16. 4 times 2 is 8, so it's minus 8k. And it says, let's go back to the question, real roots. Well, we know that if something's got real roots, the discriminant has to be positive. So this has to be greater than 0 or equal to, so it could be equal roots. So this has to be greater than or equal to 0. Nice and simple to solve. I move the 8k across. So I get 16 is greater than or equal to 8k. I divide by 8. So 2 is greater than or equal to k. And I flip the signs, because we usually write it as k, then the sign. K is less than or equal to 2. So we're just saying here, the number k could be 2, 1, 0, or any other number less than 2. Now this is quite difficult, and it combines using the discriminant and realising I had to use the discriminant with our knowledge of solving equations and inequalities. And that would usually be a grade B or A grade question once it gets that hard. But the basic 1, 2, 3 questions you should be okay with, and you also should be comfortable with being able to write that, well, I'm doing b squared minus 4ac for this question. Okay, thank you very much. Mr. Clown here, thanks for watching this video on discriminant at National 5 Maths level. Hopefully that now makes more sense. If you need any further help on this topic, check the links in the description, and please give this video a thumbs up if that was helpful for you. Thanks again, thanks for watching, and I'll see you later.